Okay, this is the fourth time I've made this video. I have two cameras, and if one of them doesn't, they both, at least one doesn't work, I'm gonna freak. You don't want to see me freak out, but you won't, because it'll be crashed video. Okay, so friction. And this gets shorter and shorter, but let me just start with the model we're going to use for static friction. So friction's pretty complicated, but this model works pretty well. And what it says is the friction force is less than or equal to some coefficient times the normal force. So if you have these two surfaces pushing together, then that frictional force depends on the types of surface, which is determined by this, and how hard they're pushing against each other. What about the less than or equal than sign? What does that mean? Well, let's look at a case. Here's a block, and it has, just sitting on a table, it has a gravitational force pulling down and the normal force pushing up, and those are the same magnitude, such that the net force is 0, acceleration 0. Okay, now I'm going to push on it to the side with a 1 Newton force. And it doesn't move. It stays at rest. That means there must be a frictional force pushing back in the opposite way of also 1 Newton. So now the net force is still 0. It's at rest and in equilibrium. Now what if I push with 2 Newtons? Well, and it still doesn't move. Then the only way this can work is friction has to be now 2 Newtons. Okay? And let's just go back. Now I'll go back to pushing 1 Newton. Then what happens? Does that stay at 2 Newtons? If it did, then the net force would be that way, and the block, I push it and it accelerates back this way. We don't see that happening. So what friction force does is it matches whatever this force, it does whatever it needs to do to make the block not slide with respect to the surface. So it goes back down to 1. So it does whatever it needs to do up to a maximum point, and that's this maximum point. So it's going to be less than that, but whatever it needs to make it not slide. So we're talking about static friction, where the two surfaces do not rub against each other. How do we determine that coefficient? Well, let's imagine that we have a plane, and we put our block on that plane, and we increase the angle of that plane until right at the point when that block starts to slide. And we do that because at the instant that it slides, we're dealing with the maximum friction force, so this becomes an equal sign. And that's going to allow us to solve for this coefficient. So let me draw a free body diagram. What force are acting on the block? Well, I have gravity. I have the normal force. This is the wrong answer that I see a lot. Oh, the normal force, straight up. It's in the opposite direction of gravity. No, it's not. The normal force means perpendicular to the surface. So it's a force from the surface pushing on the block, and it's perpendicular. So it would be like that. Now, if those were the only two forces, the block would not be in equilibrium. It would have an acceleration. So friction, in this case, would act parallel to the plane and in this direction to make the net force 0. Friction's like the peacemaker. What do I need to do to make you not move? It does whatever it needs to do, up to a point. Okay, now I want to solve for this. So I have a force diagram. The next thing to do is to choose a coordinate system. You could choose x-axis like this and y-axis like that, and that's fine. It would work. But I'm going to choose, this is my x-axis, and that is my y. And I'm doing that because then I'll have these two forces will be either in the x or the y, and that one I'll have to find components for. If I did it this way, then I'd have to find x and y components for that and that. It'd turn out the same, but just a little bit easier this way. So if you use your geometry skills, you can show yourself that that angle is also theta. I'll let you do that. So Newton's second law, or the momentum principle, or whatever you want to call it, says F net in the x direction is max. But if it's in equilibrium, that's 0. This is just at that instant when it starts to slide. So if we back down just a little bit, it wouldn't slide, but it'd be at the maximum frictional force. Okay, so what forces are in the x direction? Well, I have part of the gravitational force. This is the y component of the gravitational force, and that's the x component. I can break it into an x and a y. So the x component is going to be the opposite side of that right triangle. So I'm going to get mg sine theta. Don't fall for the trap that says, oh, x component equals cosine. That's not true, especially in this case. Okay, what about, oh, and then we have the frictional force is negative Ff equals 0. Okay? So what about the y direction? Well, F net y equals 0. It's also not accelerating in the y direction. So I have the normal force. Then I have part of the gravitational force, mg cosine theta equals 0. Now, I want mu. Mu is not in this equation. This is mu, the Greek letter mu. Mu is not in this equation. So, but I can put it in here. Instead of friction, I'll put in this. So let me rewrite this. So now I have that, but I don't have n. So I'm going to solve this for n. And then I'll substitute mg cosine theta for n up there, and I get that's an s. I can divide both sides. Well, I can divide both sides by mg, and it cancels. And I can add mu s cosine theta to both sides, and I get sine theta equals mu s cosine theta. And then I can divide both sides by cosine theta, and I get mu s equals sine theta over cosine theta equals tangent theta. Here's the danger part. The dangerous thing is to say, oh, it's a block on a plane, mu s equals tangent theta. I see that all the time, but don't do that. This is the answer to this particular problem. I could change it just a little bit, and that's no longer a fundamental idea. A lot of times I see students try to start here and use this. Don't do that. Start with F net equals ma. That's where you're starting. Because imagine if I push this block this way or change it a little bit, that wouldn't work. Okay. But in lab, this is what we're going to do. We're going to change the angle and use that to find the coefficient. Okay, I'll do kinetic friction next.